Okay, good morning. Welcome to
KidMath number 61.
KidMath number 61. This is just kind of for fun because I saw a super cool problem yesterday that Steven Strogatz posted on Twitter that comes from a Russian mathematician named Arnold. And it has to do with triangles. Now, we haven't studied geometry yet, so I'm not going to go into the details of why this is true, but we are studying quadratics, and it made me think, well, here's kind of a fun quadratic thing because the expressions are going to have some x squareds and some y squareds in them. Okay? So if you have a right triangle, see my right triangle?
Yeah.
It turns out you can draw a circle all the way around it. That's called the circumcircle. And the hypotenuse turns out to be the diameter of the circle. The hypotenuse of the triangle turns out to be the diameter of the circle. And then it turns out even more interesting than that, when you draw this line down from the right angle of the triangle down perpendicular to the hypotenuse, this is called an altitude. It divides the hypotenuse of the right triangle into two pieces, x and y, and the hypotenuse has the length, the square root of xy.
Cool.
Cool. Okay, now, so there's a few things I want to see if you can notice about this triangle. First of all, what's the diameter of the circle?
It's x plus y.
Okay. What's the radius?
Is x plus y over 2.
Okay, very good. X plus y over 2. And why is that true, by the way? Why does the geometry...
Because the radius equals the diameter over 2.
Okay, so the radius is half the diameter. You know the diameter is x plus y, because that's how I've labeled it. So halfway across is x plus y over 2. Now, you see this altitude that comes down here? From the peak of the triangle to perpendicular to the diameter there that I drew?
Yeah.
What's the longest? Can you tell from the geometry, what is the longest that altitude could be? Look at the geometry.
Well, the longest it could be, well, the radius would be this.
Yep.
So the longest it could be would be the radius.
Ah, okay. Can you draw me a triangle in blue that where this altitude would actually be equal to the radius? Can you see the triangle where that altitude?
It would be a right triangle.
Yeah, it has to be a right triangle. This has to be the hypotenuse of the right triangle. And when I drop my altitude down from the top here, from this right angle to here, I'm actually drawing a length that's equal to the radius. Do you see where that triangle is?
Well, if it was just if the top was moved over a little.
Okay, to where?
To maybe like that kind of, that's a right angle.
Okay, so
Then it would drop down and
yeah, we got to use, what's it called when we have
big dot theory.
big dot theory we have to use, yeah. So when that right triangle's peak is directly above the diameter. But this geometry gives us some very interesting algebra because we just have seen that the square root of xy, which is the length of that, has to be less than or equal to x plus y over 2. Okay? Now, these could be any numbers, right?
Yeah.
So now let's see why this is true, and this is where the some of the squares and quadratics that we've been studying comes in. So I'm going to multiply everything by 2. 2 times the square root of xy equals x plus y. You see where I got that?
You multiplied everything by 2, but shouldn't it be less than or equal to?
Oh, sorry. Good point. You're just like my professors in college. I always told me I was a little sloppy. Now, since everything's positive, since these are all distances, when I square this, I'm going to preserve this inequality. Okay, what happens when I square this side?
You get 4xy.
What happens when I square this side? What is x plus y quantity squared? Can you know that, or can you multiply it?
X squared plus 2xy plus y squared.
Okay. Now I'm going to move this over to the other side, and I'm going to get 0 is less than or equal to x squared. What happens when I take 2xy minus 4xy?
You get minus 2xy.
Minus 2xy plus y squared. And here's the last step. Why is this true? Why is 0 less than or equal to x squared minus 2xy plus y squared?
Because this is a quadratic.
It is a quadratic. That's true, but quadratics can be negative. So what, do you see anything special about this quadratic? Or this
Well,
expression?
you have 2xy here.
You do have 2xy there.
You have an x squared and a y squared here.
So what does this one look a lot like?
It looks like a difference of squares, almost.
It does kind of look like a difference. This looks like also something else you wrote on the board. It just has a minus sign instead of a plus sign. Do you see what it looks like?
It's exactly the same as this up here, except this is a minus instead of a plus.
Okay, and what was that expression equal to? What was the blue expression equal to? Where did that blue expression come from?
It came from squaring this.
Okay, so what is that blue expression equal to?
It's equal to this.
No, it's not. It's less. That's less than or equal to this. That blue expression is equal to something.
It's equal to x plus y squared.
Okay, so what do you think the purple expression will be equal to?
X minus y.
X
squared.
minus y squared. 0 is less than or equal to x minus y squared. Now, why is that true? Why is 0 always less than or equal to x minus y squared?
Well, because even if this is negative, a negative squared is a positive.
Very good. There you go. So this relationship is something we'll study much, much later on, that the square root of xy is less than or equal to x plus y over 2. That's called the arithmetic mean geometric mean inequality. It has a big fancy name, but it just comes from this picture. That's pretty neat.
Yeah.
Good job, sweetie. Good job. That was some pretty challenging math today.